Hi class, this is experiment chemistry of copper and percent yield. So this, I've tried to simplify this as much as possible. What you're going to do in this lab is you're going to start out with copper wire. It's going to go through multiple reactions that you should definitely pay attention to and study as much as possible, because there's questions all over the place in the report and in the quiz portion about the reactions. And then in the end, you're going to recover copper after all of these reactions. So we're going to compare the amount that you started with, the mass, and then the mass that you ended up with, and then set that to a percentage so we can see how much was recovered. So I pulled up the reactions. These are very important reactions, and you're going to need to thoroughly understand this. I strongly suggest, if you don't print out the PDF, then take a picture of this, write it down, copy it. It's definitely going to be asked several steps about this. And pay attention to wording. They might ask about something in a reaction after the reactions occurred for that, and not what you start with. So make sure you pay attention to what it says. When it's asking about a specific reaction, it may not be asking about the reactants, it may be asking about the products. So I boxed in that you see we start out with copper solid and we end up with copper solid. And those are the only masses we're concerned about in this, but the lab itself is going to involve asking multiple questions about everything in between. So this is a metathesis reaction, metathesis, sorry. You can say it either way. I normally say it metathesis, other people say it metathesis. It means to transpose. It's a term, a double replacement often used to describe these reactions because the cations switch place. So there's an exchange here. Also, excuse me, there's an exchange of cations, and there's an exchange actually of electrons. So you could write this out as redox and figure out certain things on some of these reactions. So that's why you see some as redox, some as metathesis. I don't know why I never say it that way, and now I am. Metathesis, a decomposition, and a redox again. If you were to work these out, you would see how the electrons are being transferred to one substance from another. There are stable products that form from this: a precipitate, a gas, and a stable molecule. So if you take a look here, you can see that there's certain things that are happening during the metathesis that match what exactly is listed here. Redox reactions, we're not going to actually go too much into this, but you definitely should make sure you're very comfortable with this, because as we continue on, even with other chapters, this stuff is going to come back, and it will definitely show up in Chem 24B. So redox, oxidation is loss of electrons, so it loses the electron, and it gets transferred to the other substance, which is a reduction. Reduction means that it gains the electron. So the oxidation number decreases, and on the oxidation side, the oxidation number increases. Decomposition reactions. This is going to involve a decomposition reaction. Make sure you're very familiar with what that means. It means that you have one reactant, and it ends up producing two products at least in here. Lab flow also refers to a decomposition reaction as a dehydration reaction, meaning a loss of water. So you have the components to have that in a substance that has H and it has oxygen, and when it decomposes, you can also remove that from the substance. Okay, so this lab is a little different, that it asks more about the series of steps than it does involve calculations. So it's really hard for me to actually show you how to do this lab. So the only thing I can stress, because it's not set up that way, study the reactions as much as you can. Try to understand as best, and I pulled up some slides to try to help you with that. So again, we don't carry about, so when we look at these reactions here, we're not worried about the mass of copper in between, because if you pay attention, in some of these, the mass of copper, we really couldn't tell because it's in aqueous solutions. They're not even in a solid form. So we wouldn't be able to just get that information. So we start with the beginning and the end. So think about distance traveled. We're not worried about the obstacles in between. We're only worried about where you started from and where you ended up. Now, in your PDF, it shows a recovered mass equation, and this is what we're going to use. So you would have your initial mass, which is what you start with, and then your recovered mass. Now, your recovered mass should always be less than the initial mass. It doesn't always work that way, and you'll find out when you do 100%. Some students will get 101. Some people will get 66. There's several reasons why some of this could happen. The more steps you have in an experiment, the more chances you have of losing mass every step. Every step could mean potential accidents happen and mistakes happen. And some of those are, for instance, not having reactions go to completion, not carrying the reactions to completion. Somewhere in a step you didn't have clean glassware, you now have impurities, and impurities will add to mass, and which is not normally supposed to be there. So these are things that ideally your recovered mass should be less than the initial mass, because you can't create something out of nothing. All right, so let's take a look at a problem here to help you understand. I made a sample problem to help you understand the lab portion and some of the quiz. You start with 6.64 grams of copper, and after a series of reactions, you end up with 3.35 grams of copper. What is the percent recovered? You're going to use the formula, which I copied here, and you need to understand which is which. So, for instance, your initial should always be more than your recovered. So you can see visibly see which is that. So the initial is going to go on the bottom. The recovered is on top times 100. And you have 3 sig figs. So I recovered a little bit more than 50% of the copper through all my reactions. Why is this a concern? Because when companies are trying to recover metals, they can't just pick them out. You actually it's a very tedious process to recover. Apple phones use a portion of gold in them, and you can't just pull the gold out. You actually have to go through multiple steps to recover the gold, and that's been used in some of the phones. At least they used to be. I taught a class and it talked about that. So there's a tedious process, but it's a lot better than just throwing those phones away. So they're trying to salvage some of what is in these so they can use them again. I copied this from your PDF. You definitely should make sure you understand this. The equations, in parentheses, match up with the equations they're talking about. So I would definitely say you write down some of this to keep notes on, to make sure that you're comfortable understanding. This is a hard one because unless you're in lab, it's really hard to visualize what's going on. And if you've been, if you have very little experience in the lab, this makes it 10 times harder to really understand this lab. I summarized it up. I did not create this. I found this off another lab that matches the copper one. I changed a few wording that matched ours, and hopefully I matched it all up correctly. But this summarizes with colors and descriptions of what's happening, and that might make things a little better for you. Again, I copied it from somewhere else, so I believe I caught everything that didn't match ours, hopefully. This is where you step in and you have to really pay attention to all the wording and the reading to make sure that you understand what the reading is. And if you then can compare it to this and see if it matches up with what you're understanding. All right, so I also found this online, and it's a diagram. You can see where a little circle route where it ends and starts in the same place of a copper solid in 1. Now the funny thing, not funny, but the interesting thing is all these numbers, the 1 matches 4.1, 2 matches 4.2, 3 matches 4.3, and so forth. So you can kind of see the steps of what's happening here. Now these don't include all the materials you've used. That would have to be involved in the reading. So make sure you understand these are just highlights of what the reaction was. Also, I want to point out that you see these brackets actually match up with your report sheet. So as you're reading, make sure that if you get confused, like number 1 wants to know the mass, so you can record the mass. Number 2, the mass of the evaporating dish, and so forth. 6 tells you what you need to balance. 7 tells you another one you need to balance, you need to complete it. So forth. It goes through the steps. This is going to be most of it's going to be asked in the lab. I didn't check it word for word, but it definitely is going to be a lot of steps are going to be asked, more than in any other lab. Percent yield is out of 100. So what happens if you're too low or higher? This is where multiple steps causes, problems. You lose stuff, you pick up impurities, reactions didn't go to completion, even though that says it did. Decanting is another important one. We've covered decanting before. So remember when I did, it had to do with filtration processes. Look that up if you don't remember. There's a lot of steps that, we're human. We make errors no matter how careful we are. Things just happen. And then tips. When completing the report sheet, read through everything. This is one I definitely suggest you take the time and read. This is not a difficult lab, and what it's asking for is not difficult, but it is tedious. So make notes, keep organized. If you need help, ask other students for help on this one. This is not one that I'm not going to discourage. If you give help, make sure why you are, just don't throw an answer out there. Explain why you got the answer. This is not a chance for just giving answers, but helping connect what's going on. That's the only way you guys really learn. But definitely ask on Pronto, put it out there. If you're struggling, so is somebody else. And I did not use units. It's funny, I've made some of these videos before the class, so I can't talk about that. I know that's one thing you guys have asked about. I did not use units in my answers, and I never do, and I always mark it right. So, just to put that out there, I don't know if the rest of them are. I'm going to go back, but this one is asking for you do a calculation, and I did not put units. I made a point to check that. And that's it. Okay, you guys have a good night. Thank you.